Welcome to PRISCI-ANTO Educational Academy. The joint probability density function of the random variable Welcome to PRISCI-ANTO Educational Academy. In this session, I am going to explain you the joint PDF of random variable, how to find the value of k as well as x and y are independent. Let us see the problem. The joint PDF of the random variable x comma y is given by f of x comma y, which is equal to k xy e power minus of x square plus y square, comma x is greater than 0, y is greater than 0, x is greater than 0, y is greater than 0. So this is the question. Find the value of k and also prove that x and y are independent. X and y are independent. So let us see how to solve this problem. So first, the joint PDF of a random variable is equal to 1, should be 1. So therefore, double integral minus infinity to plus infinity, minus infinity to plus infinity, f of x comma y dx dy, which is equal to 1. So therefore, integral, what is given here, x is greater than 0, y is greater than 0. So therefore, 0 to infinity. Integral over double integral 0 to infinity. K xy e power minus of x square e power minus of y square. So e power minus of x square plus y square can be written as e power minus of x square into e power minus of y square dx dy, which is equal to 1. This can be written which is equal to, okay, so double integral k integral 0 to infinity x into e power minus x square into dx into integral over 0 to infinity y into e power minus y square into dy. The same variable I am writing one side, right? So which is equal to. So first we will take this one. So how to solve this? Let us see. Okay, so therefore first integral I am taking 0 to infinity x into e power minus of x square into dx. So how to solve this? Let us see. So first one is, you can solve by substitution method. What is the substitution method? For x square you have to consider by taking x square is equal to s. What is the 2x dx, which is equal to ds? 2x dx is equal to ds. So which is equal to? So here I am writing 2x dx is equal to ds. So what is x dx? Which is equal to ds divided by 2. So x dx is equal to ds divided by 2. So next, when x is 0, what is y? What is s? S tends to 0. When x is infinity, what is s? S tends to infinity. So this is very important. So therefore, integral over 0 to infinity x into e power minus x square dx can be written integral for x dx. You will write ds by 2. So ds by 2 e power minus x square is equal to s. So therefore this can be written 1 by 2 integral over 0 to infinity e power minus s into ds, which is equal to 1 by 2 e power minus s divided by minus 1. Limit is 0 to infinity. So if you apply the upper limit as well as lower limit, it will be, which is equal to 1 by 2 e power minus infinity divided by minus 1 minus e power 0 divided by minus 1, which is equal to the limit. If you apply e power minus infinity will be 0, e power 0 will be 1. So therefore which is equal to 1 by 2 into 1, which is equal to 1 by 2. So what is the value? Integral 0 to infinity x into e power minus x square dx is equal to 1 by 2. Okay, so this is, we have got the value. So using this, similarly you can write, so therefore which is equal to, in the similar way we can write, which is equal to, okay, so similarly integral over 0 to infinity y into e power minus y square into dy, which is equal to 1 by 2. So therefore double integral k into integral 0 to infinity x into e power minus x square dx, okay, integral 0 to infinity y into e power minus y square dy, which is equal to 1. So substitute the values k into 1 by 2 into 1 by 2, which is equal to 1. So k by 4, which is equal to 1. So k is equal to 4. So after finding the value of k is equal to 4, you have to write the probability density function. You have to write the probability density function f of x comma y, which is equal to kxy. So 4xy into e power minus x square into e power minus y square, where x is greater than 0 as well as y is greater than 0. So this is the new PDF after finding the value of k. Okay, so next, to prove x and y are independent, okay, so to prove x and y are independent. So to prove x and y are independent. So how to prove x and y are independent? So f of x comma y or fx of x, fxy of x comma y is equal to fx of x into fy of y, or else f of x into f of y. So first we will find the marginal density function of x, marginal density function of x is fx of x or f of x, which is equal to integral f of x comma y into dy, f of x comma y into dy. Okay, so what is f of x comma y? That is given in the problem. So therefore which is equal to integral 0 to infinity 4xy e power minus x square into e power minus y square into dy. Okay, so now you have to integrate it. If you are integrating, which is equal to 4x e power minus x square, integral over the limit 0 to infinity y e power minus y square into dy. So already we have got the result for this one. Okay, so therefore which is equal to 4x e power minus x square 1 by 2. So this can be written as 2x e power minus x square This is fx of x or f of x. This is the answer of fx of x or f of x. Next you have to find the marginal density function of y is fy of y. So fy of y, which is equal to f of y, which is equal to integral 0 to infinity f of x comma y into dx with respect to x, which is equal to integral 0 to infinity 4xy e power minus x square into e power minus y square into dx, which is equal to 4y e power minus y square integral 0 to infinity x into e power minus x square into dx. So x into e power minus x into x square, okay, e power minus x square into dx, which is equal to this value already you know we have proved. So 1 by 2. So 4 by 2 will be 2. So therefore answer is, which is equal to 2y e power minus y square. This is f of y or fy of y. So next we have to prove independent is f of x comma y, which is equal to f of x or fx of x into fy of y or f of y. So 4xy e power minus x square plus y square, minus of x square plus y square is equal to 2x e power minus x square into 2y e power minus y square. So if you multiply these two, you will get 4xy into e power minus of x square plus y square. So hence x and y are independent. So hence x and y are independent. Thank you.